Good day once again, folks, and welcome to this exciting new channel called Beat Maths, where we look at all FET maths, that is from grades 10 to 12. So in the next couple of videos, I will be looking at grade 10 functions. So in today's video, I will do the linear function. In the next one, parabola, um, exponential, and hyperbola. All right, so first of all, let's look at what a function is. A function is simply a description of the relationship between two quantities, right? So in maths, we call the one quantity x, which is usually the independent quantity or the independent variable, and we call the other one y, which is the dependent one. So by quantities, it could be anything. For example, speed, where speed would be my y, and distance, which would be my x, and we are going to look at how those two are related to each other in a particular case. All right, so let's look at the linear function first. It's called the linear function. It's also known as simply the straight line function, because when you draw it, it gives you a straight line. The graph is always a straight line. So what is the general equation of a linear function? It is y is equal to mx plus c, right? And I remember various textbooks could use different letters, okay? These are variables, they are letters. So whether they use, if you see P's and Q's there, do not panic, okay? As long as you have the x, and the x has got a coefficient, so it's multiplied by something, a particular number, and the x must always be to the power of 1, right? And that product is then added to a constant a term, a constant number, like a 10 or a 5 or a -3. All right. So what do each of these mean? Let's begin with the c, right? So all that the c represents is the y-intercept. That is, where does this graph cut the y-axis? Okay, so it's the number where the graph cuts the y-axis. This one here is what we call the gradient. Okay, you can also call it the slope, or you can say it's the steepness. It tells you how steep the line is, right? Okay, so with that being said, then let's look at how you calculate the slope of a line, right? So you may have seen this in grade 9. The slope or the gradient is assigned the variable m in this case. So it is the change in y over change in x. Sorry. Okay, and I'm glad I made that error because the order is important. So if you go y1 minus y2, you must go x1 minus x2. Equivalently, you could go y2 minus y1 over x2 minus x1. It'll give you the same answer. So what is 1 and what is 2? These are just points, okay? So in this case, it means that we decided to call the first point point 1 and the second point 2. And not just any points, but there are points, very important. The 2 points must be points that lie on the straight line. So it must be points that the line goes through, right? So in this case, it would mean that this line goes through the point x1, y1. Remember, this is point 1, so these are its coordinates. And the other point would be x2, y2, meaning that it's the x coordinate of point 2 and the y coordinate of point 2. And you take those and you substitute them in there. All right? We'll do an example just now. Another way of working out the gradient is what we call the rise over the run. okay? Which is essentially the same as that. Rise is the difference in the y values. Remember, y indicates the vertical movement. And the run would be the horizontal movement, which is the change in the x's. All right, we'll do an example now using both methods so you can understand better. So let's do an example of how to work out the gradient of a line. Okay, here's an example. So they give you a Cartesian plane and they draw a line for you. There's your straight line, and they say this here is the point 0,4. Okay, and let's take another point, not on an axis. Let's take a point there, and they say that this is -6, -2, right? And they want you to work out the gradient of the line, how steep the line is. All right, so let's answer the question. Right, so the first way would be to say my gradient is the change in y's over the change in x's. Remember, the 1 and the 2, I just said they are points. So other textbooks or in a test, they could call this point A and another point B, okay, or C and D. All right, so in that case, you would have y of A, okay, minus y of B, etc. Okay, so let's answer the question then. Let's say this is my point 1, right? If this is my point 1, what is the y coordinate of point 1? If this is point 1, the y coordinate of point 1 is 4, right? So it means the gradient is 4 minus the y coordinate of point 2, which is -2. So it's 4 minus -2. Okay? All over. The x coordinate of point 1 is 0 minus the the x coordinate of point 2, which is -6. So it's 0 minus -6. And then what do? The minus and the minus become a plus, so it's going to be 4 plus 2, and that's going to be a plus again, right? So this will simply be equal to 6 over 6, okay, which is equal to 1. So the gradient of this line is 1. Okay, let's look at the rise over run method. Okay, so this is how the rise over run method works. You take the 2 points, okay? You ask yourself, if I want to move from this point to that point, how many units do I rise? Okay, and then how many units do I run? Remember, I said run means the horizontal movement. So let's work it out. If I start here and I wanna go there, remember you can only go up and down and left or right, so you can't go like that. All right, so how many units is it from here to here? Okay, you're going to look at the y coordinates because we're moving vertically. So this is at -2, okay? And that's going to be -1 somewhere, then that's going to be 0. Remember, because this is the y coordinates of this point is 0. So that's already 2 units, okay? And then to move from here to here, it's how many units? Again, I look at the y. So it means that from here to here is 4, okay? So that means it's 2 plus 4. So it means if I want to go from here to here, vertically, I will go 6 units. This is 6 units, right? So my rise is 6, okay, over my run. Now, run, how many units do I move horizontally to go from this point to that point? I look again at the x coordinates now. So from here to here is how many units? I look at the x's. So this is -6 and this is 0 from here. So that is 6 units, okay? So it's going to be 6 over 6, which is equal to 1. Right, So now, so I could have started at this point, okay, and ask myself, how many units do I go from? So how do I go from here to here? Okay, from here, let's do it that way. How do I go from this point to that point? It's rise. And all that rise means doesn't necessarily mean you have to go up. Okay? It's just referring to the vertical movement. Right. So let's do that. We're now moving from this point to that point. Let's see if we get the same answer. So if I want to go from here to here, remember, I can't go like that. So it means I have to go down. Okay? So how many units is it from here to here? It is 6 units, because that's 4 plus another 2. So it is 6. But I'm moving down this time. So that means my rise will be a negative 6. So it's going to be negative 6. M is going to be negative 6 because I went down. All right, so it's negative 6 from here to here, right? And then how many units is it from here to that way, to that side? So it's going to be 6 to the left now. But because I'm going to the left, I'm going to take a negative. Why? Because this is the positive direction, this is the negative direction. This is the positive direction, this is the negative direction. So I go 6 to the left in the negative direction, so it's negative 6 over negative 6, which is again equal to positive 1. Okay, so those are the two ways that you can work out the gradient of a line. Right, moving right along. There are a few things that I want you to know about a gradient. Okay, so if I've got a Cartesian plane there, and let's draw a line. So if my line leans this way, my gradient, you need to know that my gradient will always be positive, greater than 0, meaning it's positive. Okay, bear that in mind. So if it's leaning this way, right? If my line is leaning this way, my gradient will always be negative. I'll always get a negative answer for the gradient, a negative number. Okay. And then there are two other very interesting ones. If my line is horizontal, okay, parallel to the x-axis, right? My gradient will be equal to 0. Okay, if you want to think of it this way, there is no steepness, there is no slope, right? It's perfectly horizontal. My gradient will be 0. And you can actually prove this using that y1 minus y2 over x1 minus x2. Take any 2 points, substitute them into that formula, and you'll get a naught, right? And the last one that I want us to look at is this one, a vertical line. If my line is vertical, my gradient is undefined. Again, if you want to prove it, take the gradient formula, substitute 2 points. You will end up with a 0 at the bottom. And you and I both know that you cannot divide by 0. If you divide by 0, you get an undefined answer. We say the answer is undefined. And if you press it on your calculator, the calculator says error, math error. Okay. All right. You'll see maybe these two when we do more examples, right? Let's then jump to, this is just a crash course. Let's then jump to, how do I now sketch a straight line, a linear function, if they give me the equation, right? So for example, they will say sketch, let's say y is equal to, I don't know, 2x minus 2. Let's say sketch that. Now, there are two ways that I want you to know, and you can use any. The first one is what we call the dual intercept method, right? Dual, remember, means two. Dual intercept method. So that means that you are working out the intercepts of both the x and the y axis. So you're looking at where does your graph cut the x axis and where does the graph cut the y axis. Find those 2 points, join them with a straight line. Okay, so let's do that. Let's answer this question using the dual intercept. So what you do is let's first find the x-intercept. X-intercept. We always say let y equal to 0. If you want to find the point where the graph cuts the x-axis, you let your y equal to 0. Why? Because if you have your Cartesian plane there and you are looking for this point here, for example, right? Now, this is a point on the x-intercept. Now, all the points on the x-intercept have a y-coordinate of 0, okay? So any point that lies on this line has a y-coordinate of 0. For example, this here is 0, 0. And for example, let's say that is 4, 0, okay? This here, let's make it negative 1, 0, because it's on the x-axis. And this here, for example, would be, I don't know, negative 3, 0. So you see what is common to all those points is that they have a y-coordinate of 0. Okay, so that is why we say in order to find the x-intercept, we let y be equal to 0. Okay, so we go to our equation. And we're going to, wherever we see a y, I'm going to put a naught, right? So remember, we have y is equal to 2x minus 2. I'm going to substitute this y with 0. So I will have 0 is equal to 2x minus 2. You've got a beautiful linear equation there, solve for x. I'm going to take this 2 over to this side because I want to have x left on its own. So 2 is equal to 2x, right? And how do I solve for x now? I need to get rid of this 2, so I divide both sides by 2. So my x is equal to 1. So it means that this graph, this function, when sketched, it cuts my x-axis at 1. Right. Let's work out the y-intercept. For the y-intercept, we say let x be equal to 0. Again, why do we say let x be equal to 0 for the y-intercept? Because if you look at the y-axis, every point on the y-axis has an x-coordinate of 0. Okay, if you don't believe me, this is 0, 0. Okay, it's on the y-axis. This here is 1, 0. This here, let's say minus 2, 0, etc. Okay, sorry. I beg your pardon. Okay, so this would be 0, 1. This one here would be 0, minus 2. Okay, so what do you notice? They all have an x coordinate of 0. So that is why we say let x equal to 0. So let's apply that here now. So remember, y is equal to 2x minus 2. Where I see an x, I'm going to put a naught. So y is equal to 2x. So 2x means 2 times x. So it's going to be 2 times 0 minus 2. And 2 times 0 is 0. So it's 0 minus 2. And this is simply minus 2. So this graph cuts my y-axis at minus 2. Okay. And then let me sketch it. Let's sketch this graph. Where am I going to sketch it? Here, right? If that is my Cartesian plane, let's make it green. My x-intercept is 1. So if that is 1 and that is 2 and that is 3, it means my graph cuts the x-axis there at 1. And where does it cut the y-axis? At -2. So if this is -1 and this is -2 and that is -3, it will cut the y-axis there. And then I take a ruler, join these two with a straight line. Going that way, put an arrow because it goes on and on forever. And there is my straight line. Okay? I want us to talk about this. Did we have to do this? And the answer is no. Why? Because there it is in my equation. Okay? The equation can tell you what the y-intercept is. The only thing it can't tell you is the x-intercept. This is my c. Remember, y is equal to mx plus c. So my c is -2. So I could just read that from my equation. Okay, so that is the dual intercept method of finding, of sketching